Hey everybody, happy Friday here. Sorry, I gotta fix my crazy looking hair here. All right, hopefully everyone's had a good week. Here we go. We're going to have a video today talking about Paleozoic Ohio. I'm going to go into some detail about what life was like for the animals that they were fossils of that we're studying this week, that we talked about the identification on Wednesday. On Thursday, that video, I showed you some samples we found. And now I just want to go over the details of what Ohio was like during this time period when they were alive and how we know that, right? So this is a slideshow that I'm going to be working through. Your work is going to be this Google Doc right here. And you'll see there's just a series of questions. And I have lifted these directly from the slideshow. So for example, this question right here, what is plate tectonics? This next question here says there are three geologic time periods, the Paleozoic, the Mesozoic, and the Cenozoic. Which time period is missing in terms of fossils in Ohio? I'm going to go over that. Are there any dinosaur fossils in Ohio and why? And the Paleozoic era was approximately how many million years ago? During the Paleozoic, Ohio was a blank, fill in the blank, and then three notes or facts about fossils. So real fast to go over this, I'm going to go over the answer to every single one of these in the video. You are more than welcome to pause and rewind as needed, but the answers are in the video. If you turn this into me without answering this basically correctly, because this is straightforward, I'm going to give you 0 and send it back to you because you didn't watch the video. So not to sound harsh, but that's how it's going to go. That would be like you sitting in class and not writing down a single thing for the day. The other thing about notes and facts about fossils, a couple things. You are not allowed to say they are cool. I know that, okay? And you're not allowed to say they're really old because, well, honestly, duh. We all know that fossils are really old. That's not a fact or a special note at all about that. You are allowed to write anything you want about the fossils I'm talking about in this video, but it needs to be facts or notes from the video, not something that you're typing in quickly because you want to show your mom and dad that you're doing your schoolwork so you can just send it in quickly and play Fortnite. So you don't want to do that, okay? All right, here we go. Moving on, rant over. All right, Paleozoic Ohio, here we go. All right, so if you take a look at that first one on the screen, if you think back to our guidebook, this is an excellent example, an extremely rare example because it's in such a good shape of our state fossil. We do have a state fossil, and I'll give you a moment here to think to yourself if you can identify that yourself. If you said a trilobite or a trilobite, depending on how you pronounce it, you are correct. All right, so Ohio has changed. We have to keep in mind that Ohio has not always looked the way it does right now, where we have farmland and cities, okay? It looks like that now, but it has not always been this way throughout the years, right? The main reason why is plate tectonics. This is something that I talked about in my video about slow and rapid changes when I talked about earthquakes and volcanoes, because plate tectonics are the reason why we have those things, right? So the idea is with plate tectonics down here, and this is the answer to that first question. So if you need to pause it, you can. Plate tectonics is the theory that our Earth's outer shell, or the crust, is divided into several plates that are gliding, moving over the mantle. So if you think, and I'm going to show you some videos here in just a moment, sorry, not videos, but pictures of what this is showing, is that we have layers to our Earth. We have the crust that we're on now, and if we were to go down deep enough, we would hit the mantle, which is this gooey, thick, kind of melted, kind of gooey, kind of like hot bubble gum that you just put in the microwave or whatever. Not quite liquid, but almost there. Rock, melted rock, right? And that's the stuff that squeezes up through the volcanoes and then comes out as lava. And then if we were to go further, if we didn't burn to death yet, which we would have, we would get to the core, right? So our Earth is split into these layers. And these first two pictures here, this picture here, and then this picture here, shows a really nice cross section of what that looks like. We have our crust, or the lithosphere. You guys are going to learn all these words and more about this in 7th grade science. Here we have the mantle. So like I said, it's that gooey, not quite liquidy, but kind of gooey in between. Think about like maple syrup. That's good. So think about like really flaming hot death gooey maple syrup. Anyways, here of melted rock, and then we have our outer core and we have our inner core. These red arrows, they're going up and then they're coming down and they're going back up again. Here they have the arrows, same thing, going down, coming up, going back down again. Right here, they're using this beaker of water. And I want you guys to think about that pot of water that I had in class when we were talking about heat and we were talking about convection. That is what's going on in the center of our Earth. When we think about lava lamps, for example, they are called that not because they're made out of lava, unfortunately, that would be awesome, but they act the way magma acts, right? So technically they should be called magma lamps, but whatever. So what happens is the liquid in this jar, remember how convection works, heats up and it rises because it has a lot of energy. It cools down, so it sinks. As it gets closer to the heat source, it heats up again, rises, cools down, falls, and that's what's going on if in the mantle with the magma. It heats up, it cools, it falls, it heats up, it rises, and in this process, it's going to cause volcanoes. It's going to cause earthquakes in some cases, and that's what happens. So our crust is this layer of rock, and this broken into these sections, and these sections are moving. If you look here at South America, and if you look at here, the continent of Africa, Africa is not a country, it is a continent made up of countries. But anyways, you will see that one of the ideas that gave Alfred Wagner the idea, this is the guy who originally came up with the idea of plate tectonics, is he looked at the map and he basically said, look, if you look at South America and if you look at Africa, they basically fit in with each other as puzzle pieces, okay? Another piece of evidence was we found many, many types of rocks and fossils in South America, and they have identical matches in Africa. Same types of animal fossils here, same type of animal fossils here, same type of plants, same type of plants, same type of rocks, same type of rocks. And there's no way that these, specifically dinosaur fossils, there's no way these dinosaurs were swimming across the ocean like that. And we don't see that in other places in the world. For example, like T-Rex fossils are only found in North America, not in Europe, because Europe and North America were separated by the time T-Rex was around. So for animals to be in both of these places basically at the same time, that meant that these were connected at some point. And because of plate tectonics, they've moved away from each other. So plate tectonics is the reason why Ohio has changed as much as it has, and the rest of the world. But I'm focusing on Ohio right now because that's us. It's where we live. So this is where the continents are today, but they have not always been in the same place. So this video does a really nice job here of showing plate tectonics and how we think the Earth has changed over the millions of years. So let me get this going for us. Look here, this is the continent of South America and Africa right now. This is North America, this is started Asia. This is the Ice Age, and then modern day. Here, I want to bring it back here real quick of something because some of you may be wondering, how do we know that this even happened? So I want to show you this part real quick, and then I need to move on because it's not quite the time period we're talking about. This is what is going to be modern day North America. You can see part of the Florida down here. I mean, that's going to be modern day Florida right there. This is areas like Utah, Colorado, out west. The reason why we know that at one point there was a shallow, warm sea in the middle of the North American continent is because we are finding fossils of ocean animals in the middle of the desert. So those ocean animals are not going to just crawl up out of the ocean, travel hundreds of miles, and then die in the desert. So if we're finding ocean fossils in a desert, that is proof to us that at some point that used to be an ocean. Down here in northern Africa, what is going to be future day modern, northern Africa, right? Where Egypt, for example, is going to be right around this area. That's where Egypt is roughly now. We find skeletons of extinct whales. Okay. So for those animal fossils to be there, that is proof that that environment is totally different than how it used to be. And that's where we're going to be going with what we're talking about now. All right. So let me get my mic plugged back in again. Good. All right. Excellent. So here we are. So geologic looked at this with our fossil of the day, starting out with most recent Cenozoic, age of mammals, Mesozoic, age of reptiles, Paleozoic, age of fish. In Ohio, we have fossils from, and this is another question on our sheet, so if you need to pause this or rewind it, now would be a good time to do that. We have fossils from the Paleozoic. We have fossils from the Cenozoic eras, but there is no fossil evidence from the Mesozoic era at all. This entire section of Earth history is missing from Ohio. They have plenty of it in other places, like in Colorado, for example. There are dinosaur fossils all over the place in Colorado. Colorado's state fossil is the Stegosaurus. That's how many dinosaur fossils they have out there. But in Ohio, nothing. So that means there are no dinosaur fossils in Ohio. I hate to tell you, but that is the truth. So if you find a fossil and you think it's from a dinosaur, I hate to break it to you, it's not. It may look like it's from a dinosaur, but it is not. We have 0 dinosaur fossils to date found in Ohio, and here's why. The main thing is there are several things to blame. Plate tectonics, the shifting of the Earth, right, we talked about, weathering, erosion, but most of all, the glacier. If you remember me talking about this a few lessons ago, the glacier coming through Ohio melted, and then that meltwater washed away the layers of soil that contained any possible dinosaur fossils. So what happened was when this glacier came through, it first of all scraped away all those layers of dinosaur fossils and sediment from that time period. And then when it melted, it washed them away. So there's no doubt that dinosaurs lived and roamed in our area. But when that glacier came through during the Ice Age, it erased all that evidence. That would be like if I took our creek from the classroom and I just dumped a giant bucket of water on there. It's going to wash everything away. It is gone. But don't be sad. Ohio still has some amazing fossils like that guy, that guy, that guy. This one, that was good. That's a good one right there. So we're going to be talking about all of these. So we have great examples from Paleozoic and Cenozoic, but no Mesozoic at all. So looking at our time scale, the Paleozoic, the fossils that we've been talking about and identifying this week, is approximately 542 to 250 million years ago. Okay, so we are looking through this time period right here, the Paleozoic, the fossils in this time period, the age of fish that we have in Ohio, right? It's known as the age of fish due to the number of fish and ocean animal fossils that are found at that level. Okay, so that's why we get that name. So we're looking at a range of 542 to 251 million years ago. Paleozoic fossils are found in all regions of Ohio. So this is a map of Ohio. We're down here. Well, right now I'm right here in Hamilton County. You guys are in Claremont County. So we are in Area 5. I found this map online, and I'm just going to use it for my purposes because the fossils you find in Area 5 are going to be very different from the areas in Area 4, in Area 3, and Area 2, and Area 1. So the fossils that we find in our backyard, the trilobites, the crinoid stems, the cephalopods, the brachiopods, all those great things, we find a lot of those in Area 5. You are not going to find any of those in Area 4. So we'll talk about that later. All right, so roughly about 500 million years ago, this is right around where Ohio um, would have been. Okay, and we're using the fossils as evidence of how we know this. Nobody was back there 500 million years ago to say like, hey, everybody, this is what it looked like. Here's a picture of it. That's not what happened, unfortunately, but the fossils tell the story. During the Paleozoic, Ohio was a warm, shallow sea. Not a deep ocean, but a nice, warm, shallow sea with lots of sunlight and a lot of life. And how do we know that? Because when we go to a warm, shallow sea today, this is what we see. Take a look at that. We see fish and animals swimming all over the place. We have coral reefs that are just packed in with animals. And we know that because when we look at a rock, and we see that many different fossils in one example, that tells us that there were just massive amounts of life living in one space. The word for that is biodiversity, meaning bio meaning life and diversity meaning there's a lot of it and it's different. This is just one picture right here. And look, there's a shark, there's coral, there's anemones, there's all sorts of different types of fish. So we know this by looking at, warm shallow seas today. Here's another shot of that this is an excellent example of biodiversity, the number of animals squeezed into one tiny spot. So we go to modern day areas to help us study extinct areas. We look at modern day animals to help us learn about extinct animals. So here we go. So Ohio was a warm shallow sea, and this is what we think it would have looked like back then. So this is extinct Ohio. These animals lived in Ohio. All right. We live in section 5, and we find these following fossils: our trilobites, our gastropods, our horn corals, cephalopods, crinoid stems. But that's the crinoid head, not the stem part. Bryozoan, and then our brachiopods. Okay, so these are common fossils in our area that lived in these warm coral reefs. And here's a great model of what it would have looked like. All these animals crammed into one spot, living, dying, feeding, eating each other, trying not to be eaten. It's great. So if you look at that model real quick, do you see any of these animals that we've talked about? For example, like the crinoids, they're right there. And the horn coral, right there. Bryozoan, the coral looking things that look like little tree branches, right there. The cephalopod, right there, going after the trilobite, and then filter feeding as it goes, the brachiopod. Great, great description. Now the colors, we're not really sure, right? We are looking at modern day examples to give us an idea. We don't know what color the cephalopods were, but we have this idea because we look at modern day octopuses and we think, okay, well, they have spots. Maybe they had spots. We don't know what color bryozoan were, but we can study modern day coral and get an idea. We do know what crinoids looked like because they're still alive now, but maybe these were a different color. So a lot of stuff is based off fact. The other stuff is this good guesswork. So these are 2 videos I'm going to link in the classroom. Check them out. They're pretty cool. This is just another artist's idea of what maybe these things looked like. This person drew trilobites being green and the cephalopod having striped patterns. And this is based off of a modern day example of a cuttlefish. It's really neat. So these animals are extinct, but they do have modern day relatives. So for example, a trilobite closest modern day relative is a horseshoe crab. These guys are really, really neat. I have a dead horseshoe crab in my classroom, but unfortunately I cannot show you this. But I want to show you this video here. These animals are really, really unusual. I have the audio off because I like my commentary better than theirs. These animals have been on our planet since before the time of the dinosaurs. These guys made it through some big extinctions, but they are really, really close relatives to the trilobite because if you look at their bodies, we know this is how trilobites moved around because we have fossils of the tracks. Here's a fossil of a horseshoe crab, and you can see where it left the tracks behind. We have examples of trilobites that have done this, right? So they have the segmented body, they have the eyes that are incorporated in part of their shell. And I want to show you this part here where they're turned over. They have these segmented legs underneath. These are amazing animals. Take a look at that again. So we know trilobites had legs like this because we have fossils of them, right? So these guys are great examples of modern day relatives of trilobites. Okay, so our next one are our brachiopods. You know, they're close relatives to clams and things like that. But our cephalopods, a close relative to them, are this really, really neat ocean animal. It is called a nautilus. And here is a video of the nautilus. Right, which one? Right here. Excellent. So just kind of show you what these things look like. These guys are really, really neat. So they are these little relatives to squid and octopi, and they live in that shell. That shell grows with them as they grow, and that shell is partially filled with air and partially filled with the animal, and it just bobs around. That's what it does. So in that one, and it will suck in water and squirt it through that tube and just kind of move itself backwards in jet propulsion. So a nautilus is a really, really neat animal. Take a look at that again. It has that eye right there. And if it needs to close up its shell for protection, it will do that. So that is a relative, a living day relative to our extinct cephalopods. So there they are again. And this is a cross section of the shell and what it looks like. And I have a fossil sample. I'll have to get a picture up to show you guys that we know that these guys, their shells were hollow to a point because we have fossils that show that air tube that would go through. And as the animal would grow, it would add a new chamber to its shell with every year. I don't know if that's on a yearly cycle or just as it grows, but here's the actual animal. The rest of the shell is hollow, so it can kind of bob around through the ocean. Okay. So we're going to leave it here because as time goes on, animals get more advanced, and the oceans start draining and things start happening in Ohio. That's really amazing. So we're going to talk about like this guy, Brotholepses. All right. Thank you very much, guys. I hope you have a great day. If you need any help, please let us know. We are here to help you guys out. Take it easy. Have a great week.